Algebra Honors, Unit 7, Day 8. These are our actual notes on how we factor by grouping. Unit 7 is polynomials. So thanks for tuning back in again here. And I'll do my best to do these correctly the first time. Let's see. All right. So you know you can factor some of your higher degree polynomials using grouping. So what I am talking about is we're going to have polynomials where we might have something like x to the third or maybe even x to the fourth. Okay, we have factored by grouping with lower degrees, 3x squared. This would be a trinomial, 3x squared plus 10x plus 8, right? But we broke up 10x into 6x plus 4x, so it's the same amount, so that we could factor by grouping the first two terms and also then the second two terms, pulling out common factors from just those groups, okay? So we've already done that sum. In this case, 3x squared plus 6x, we pulled a 3x out of there, and we had x plus 2 left. We pulled from 4x plus 8, we pulled out a 4 and had x plus 2 left. So we could see we had a common binomial. So we were factoring out a binomial instead of a monomial. That's the big difference here when we are factoring by grouping, usually. All right, so we're going to factor 4-term polynomials. First, you want to just double check and make sure it's in standard form. Make sure you are all the way simplified and in standard form, which means highest exponent first. Always look for a greatest common factor and factor that out first, okay? Then, since you're in order, you're going to group your first two terms together and your last two terms together and try to factor a greatest common factor from each of those smaller groups. Okay, and if you have a common binomial between the two, you're going to pull it out. So, do check your answers. X cubed plus 7x squared plus 2x plus 14. I'm looking at all of those terms and I don't see anything I can pull out of everything. So I'm going to group the first two together and the second two together, okay? X cubed plus 7x squared. What can I pull from those guys? X squared. So I take x cubed divided by x squared, I'm left with x. 7x squared divided by x squared, I'm left with 7. I've just done my first two. Now I'm going to group my second two and see what I can pull out. I'm going to pull out a 2, and so 2x divided by 2 leaves me with x. 14 divided by 2 leaves me with 7. Now I see that I have a common binomial, x plus 7. I'm going to pull that out, and I'm left with x squared plus 2. Okay, again, you already know how to pull out a common factor. In fact, we just did it. When we had x cubed plus 7x squared, we pulled x squared from each of those two terms. Okay, we pulled a monomial from each of those two terms. The thing that is slightly more complicated once we have that next line is we're pulling a binomial from two big terms. Okay, that's all we're doing. But this is your answer. If you multiply it back together again, you're going to get x cubed. Outer is going to be 2x, inner is going to be 7x squared, and last is going to be 14. So it's not in order right now just because I used FOIL, but if you look, I have the same terms, x cubed plus 2x plus 7x squared plus 14. Always check your work, okay? That was me checking. Okay, 5n cubed minus 10n squared plus 3n minus 6. I don't see anything that comes out of all of them, so I'm going to group. And I'm going to pull 5n squared, and I have 5, oops, I don't have 5n, I just have n. When you divide 5 by 5, you just get 1. So I'm left with n minus 2. N minus 2. Okay, over here, plus 3n minus 6, I'm going to take out a 3, and I'm left with n minus 2. I love that because I have a matching binomial, so I have n minus 2 from both of them. What I'm left with is 5n squared plus 3. You can check your work. N times 5n squared is going to be 5n cubed, and then outer is 3n, inner is negative 10n squared, and last is negative 6. So I know it's going to be out of order because I'm not in descending order, but I have 5n cubed plus 3n minus 10n squared minus 6. That worked. Okay, let's see what we can do here. 6n cubed, 3n squared, 8n, 4. I don't see any common factors. So pull from here. I'm going to take out 3n squared, and I still have 2n plus 1 pull from here, I'm going to pull out 4, and I'm going to be left with 8n divided by 4 is 2n, 4 divided by 4 is 1. All right, 2n plus 1 times 3n squared plus 4. That is my set of factors, my binomial factors of this big polynomial. M cubed minus m squared plus 2m minus 2. These guys get to lose m squared. Let's pull that m squared out, and I'm left with m minus 1. These guys, I'm going to pull out a 2, and I'm left with m minus 1. So m minus 1 times m squared plus 2. If I check it, m times m squared is m cubed, outer is 2m, inner is negative m squared, last is negative 2. So I know this is out of order, but m cubed minus m squared plus 2m minus 2. Check, check. All right, so 35xy minus 5x minus 56y plus 8. I can't take anything out of all 4, so let's pull 5x from these two and get 7y minus 1. And let's pull negative 8 from these guys, and I'm left with 7y minus 1. Okay, so 7y minus 1 times 5x minus 8. That's going to be my answer. All right. mz minus, holy moly, mh squared minus 5nz plus 25nh squared. That is a whole lot going on. Am I in order? Well, we do like to have it in standard form. I don't have anything that I can simplify. H is my first letter in the alphabet, so I think I'm going to put this in a different order. I think I'm going to try it like this, but you guys are doing this with me the first time. Negative 5mh squared. Let's try plus 25nh squared. And then maybe plus mz. Done with that. Minus 5nz. Okay, so yeah, I'm going to try that, because now at least I can see that I have matching variables with the matching exponent that I could pull out, maybe. I hope this is going to work. I'm going to group those two, so I'm going to pull out, oh, and now I have to decide whether I want a negative or positive, but I'm going to pull out negative 5h squared. Let's just see what we get here. I may have to come back and pull out a positive 5 in h squared instead. So negative 5h squared, when I pull that from here, I'm left with positive m minus 5n. 25 divided by negative 5 is negative 5. 8n, h squared divided by h squared is 1. Okay, over here, if I pull z, where's z? Where did z come from? Oh, I've got two z's. If I pull z, I'm left with m minus 5n. Oh, whew, look at that. That's good. Okay, I'm going to pull z out of these, right? This is my second grouping. I'm going to say plus z times, I'm left with m minus 5n. Well, isn't that lovely and convenient? Because that's what I was looking for. M minus 5n is what I'm going to pull out. So I have m minus 5n. And I'm left with negative 5h squared plus z. That was a doozy. So you do always want to follow those instructions and make sure you're in standard form as much as you can be. And I was pausing here because I realized if I didn't end up with matching binomials, if they were really close but one was positives and one was negatives, I might have had to pull out positive 5h squared. It turned out I did the right thing the first time, but sometimes you have to finagle a little bit. So just saying that. Okay. Factor, and actually let me just take a quick look. There's nothing that I could pull out of those guys. I want to look at all of my answers so far and make sure there's nothing that I could factor out even more. They're looking pretty good. I think I've managed to get all the way down for all those. Okay, factor by grouping. So this is a whole lot of practice. A whole lot of practice. I suggest you try these first and then pause the video. Right, so pause the video, then try these, and then come back. It's really better if you make sure you can do it on your own, because watching somebody else do it is usually a billion times easier. 2x to the fourth minus 8x cubed plus 10x squared minus 40x. I can certainly take an x out of everything, and it looks like I can take a 2 out of everything. So I'm going to say 2x first leaves me with x squared minus 4. Sorry, it leaves me with x cubed. 4 minus 1 is 3. Minus 4x squared plus 5x minus 20. Oof. And since I started with a bracket, I'm going to end with a bracket. Now I'm going to try to do this by grouping. Am I in order? I am in descending order by exponent. So I still have 2x on the outside. I'm going to pull x squared from here, and I'm left with x minus 4. And I'm going to pull 5 from here, and I'm left with x minus 4. Okay, keep that 2x on the outside. Pull x minus 4 from each of these big terms. You're left with x squared plus 5. All right, remember when you check, you're going to do your x times x squared. You're going to do that trinomial first. So I have the binomials that are going to become a trinomial. X times, or maybe not, x times x squared is x cubed. Outer is going to be 5x. Inner is negative 4x squared. Last is negative 20. And of course, I need to still multiply that all by 2x. So my final, when I check, I'm going to distribute that. This is just me checking, okay? I'm going to have 2x to the fourth plus 10x squared minus 8x cubed minus 40x. I know it's out of order because when I used FOIL, I kind of bumped it out of order. 2x to the fourth plus 10x squared minus 8x cubed minus 40x. Thank goodness that checked out when I checked it. So that is my answer. All right, 4x to the fourth minus 8x cubed plus 12x squared minus 24x. I'm going to definitely pull x. I'm going to definitely pull 4. Let's take 4x out. I'm left with x cubed minus 2x squared plus 3x minus 6. Okay, and I'm in order, so I'm going to group it straight away. I'm going to have 4x times x squared times x minus 2 plus 3 times x minus 2. And I pull out x minus 2. I'm going to pull out that binomial, so I have 4x times x minus 2, and I'm left with x squared plus 3. X squared plus 3. That should be it. All right, definitely you're trying these, right? You're trying these and you're trying them on your own and then checking your work. Okay, 40n to the fourth minus 60n cubed minus 50n squared plus 75n. I'm certainly pulling an n. I'm certainly at least pulling a 5. Can I do 25? No, I really can't. So can I do 15? No. All right, I'm going to pull 5n out. I hope that's enough. That leaves me with 8 times 5 is 40, yeah, 8n cubed minus 5 goes into 6 one time, 12, sorry, and then squared minus 10n plus 5 goes into 7 one time, 15, just like so. Boy, I hope I factored that right. Crazy. It feels too easy compared to some of them. I'm going to break these into 2 groups, so I have 5n times. I will pull 4n squared and leave myself with 2n minus 3. I'm going to take out negative 5, so minus 5, and I'm left with 2n. 15 divided by negative 5 is negative 3. Well, that's looking good. 5n. I'm going to pull out that binomial, so 2n minus 3 times 4n squared minus 5. That's it. 12x cubed minus 36x squared plus 60x minus 180. I can pull out maybe 12. Does 12 go into 180? I don't know. Yes, the calculator says it does. So let's pull out 12 from everything first. 12 times x cubed minus 3x squared plus 5x minus 15. And I'm factoring by grouping. I'm already in the correct order, so I'm going to say 12 times, I'll pull out x squared. X squared leaves me with x minus 3. And here I'm going to pull out 5, and it leaves me with x minus 3. And you know that these problems that we're giving you, they work out lovely like this because we have given them to you intentionally with binomials that you can find. There will be some problems where there is no common factor, and it might just be prime, and that's okay, but we generally give you ones that there are factors you can find, just so you know. So 12 times x minus 3, I'm pulling that from each of those big super terms, and I'm left with x squared plus 5. All right, 60x cubed minus 90x squared minus 30x plus 45. I'm guessing that 15 is going to be my big number. So 15 times 4x cubed minus 6x squared minus 2x plus 3. I keep 15 and I'm going to take out 2x squared. That leaves me with 2x minus 3. I'm gonna just take out -1. I want to take out -1 because that leaves me with 2x minus 3, and so I now have matching binomials. Okay, I had to make a decision there for a moment about whether I was going to take out -1 or +1. I took out -1 so that I have matching binomials. Keep that 15 on the outside, pull those 2x minus 3's, and you're left with 2x squared minus 1. All of this divisible by 3 for sure, and y. So let's take out 3y. I have 8y cubed plus 2y squared plus 12y plus 3. And I'm in order, so it should be pretty easy to find my common factors. I'm going to take out 2y squared, and I have 4y plus 1. Here I'm going to take out 3, and I have 4y plus 1. Keep that 3y on the outside. Pluck out 4y plus 1 from each of these inner terms, and I'm left with 2y squared plus 3. All right. I need to find linear dimensions, linear expressions for the possible dimensions of each rectangular prism. Rectangular prism, and we are talking volume, basically volume of a box. We know volume is length times width times height. Yeah? Yeah. Volume is length times width times height. So I want to find a length and a width and a height. So let's see if I can factor that out. Notice that as we've been factoring all these things, we have often had 1, 2, 3 factors, 3 things that we were multiplying together. So that's what I'm hoping is going to happen for me when I factor up the volume. Okay, I have 12x cubed plus 34x squared plus 14x. All I'm doing is just rewriting that so I can see it. I can definitely take an x out. I can definitely take a 2. I cannot take 4. I cannot take 7. So I think I'm going to just say 2x. And I have 6x squared plus 17x plus 7. Oh, so now maybe I can just factor that trinomial. Let's see. Okay. So we know that I'm hoping I'm going to have 2 binomials, right? We hope I'm going to end up with something like that. Let's see if we can factor out 6x squared plus 17x plus 7. Let's try. I need 2 numbers that multiply to give me 42. Yeah, because 6 times 7 is 42. And they have to add up to be 17. 6 and 7 added is 13. So I hope I've been recording. I'll be sad if I haven't. 14 times 3 is 42, and 14 plus 3 is 17. So those are my magic numbers, but because my leading coefficient here is 6, I'm going to make my box, or I could use grouping method. It's totally up to you. I'm going to make my box, and I'm going to have 6x squared here, and then my last term is 7, right, because I'm just doing that trinomial. I'm going to have 14x and 3x. Using my box, I can pull out 2x, and I can pull out just a 1 here. I can get 3x, and I can get 7. My binomials should be 2x plus 1 and 3x plus 7. I do want to check this. I really do. So I'm going to multiply my binomials first, and I get 2x times 3x is 6x squared. Outer is 14x, inner is 3x, so that's 17x. Last is 7. Well, that at least is what I thought I should start with. Now I'm going to multiply out that 2x using distributive property. Okay, so you know this is me checking, right? This is me checking. So 2x times 6x squared is 12x cubed. Yes. 2x times 17x is 34x squared. 2x times 7 is 14x. It sure looks like I worked that out okay. So my 3 dimensions are going to be 2x and 2x plus 1 and 3x plus 7. I don't know which one's going to be length or width or height, but I do know that those are the 3 different possibilities. Last one, let's do it. 10x cubed plus 65x squared plus 105x. They're certainly divisible by 5. They're not divisible by 10. So let's do 5x. 5x times 2x squared plus 5 goes into 6 one time, 3x, like that, right? 65x squared divided by 5x is 13x. 5 goes into 105, 21 times, and x divided by x is just 1. All right, again, I have this trinomial, so I can either do it by grouping or by box. I prefer the box, so you do it by grouping if you want to. I'm going to do the box. I need 2 numbers that, and remember, I'm hoping to get 5x times 2 binomials like that. I'm hoping that's going to be my answer. 2 numbers that multiply to give me 42. 2 times 21 is 42. Oh, 42 again. And they have to add together to give me 13. Hey, that one's easier. 6 times 7, yeah? 6 times 7 is 42. 6 plus 7 is 13. Plunk all your stuff in. I got 2x squared in the top left, and I've got 21 in the bottom right. I know my magic numbers are 6x and 7x. If you wanted to do this by grouping, you would be saying 2x squared plus 6x plus 7x plus 21. You do it by grouping that way. I'm doing box, so I'm going to pull out 2x from the top, 7 from the top. Side to side, I'm going to get an x, and I'm going to get 3 out of there. So hopefully I have x plus 3 times 2x plus 7. Check it. So I have x times 2x is 2x squared. Outer is 7x, inner is 6x, so that's 13x. And last is 21. That is at least the trinomial I thought I should have. And I'm going to multiply that all by 5x. So I get 10x to the third plus 65x squared plus 105x. Is that what I started with? 10x cubed plus 65x squared plus 105x. Well, aren't I thrilled because I checked it and it worked. Thank you so much for watching. I hope you did try a bunch of those on your own because that's the best way to make sure you're understanding. And we'll see you for the next video.